Hey guys, it's Mr. Ellis. In this video, I'm going to talk about pulleys, our next topic. And the idea here is that we're going to define what this is and get the simple principles out of the way at home so that next class we can just start by practicing how do you deal with this in problems and in more difficult situations such as with friction. So right now we're going to look at this with no friction, just how do you deal with these connected objects when there's a pulley and one's hanging. This is a little bit different than what we just discussed. Then you'll answer the questions in the forum under this video, and there's going to be some kind of simpler questions on WebAssign for you to do as well before Tuesday. All right, so let's get started. Like in this case, we have two objects connected by a string. It's just that one of them is now hanging off the table. They're not both on the table, and there's a pulley. Pulleys we're going to treat as sort of magical. Like they don't have mass, there's no friction, they don't affect the tension. It's just going to bend the line of action. And this is kind of nice because this may seem like now there's X and Y components, but really we can just treat this like it's all one axis. M2 pulls to the right, M1, if there was friction, might pull to the left, but we don't have to worry about X's and Y's if the pulley is just bending the line of action. And I'll talk about what that means in a sec. So let's look at this. If we draw free body diagrams, we can see we definitely have X and Y components to these forces, right? There's X forces, there's Y forces, but with the pulley, what's kind of nice is we can just consider that the X-axis sort of bends around the pulley, and so M2G down here in the bottom right corner is pulling to the right kind of, and so we can treat when we look at the whole system, we can kind of consider what's pulling to the left, what's pulling to the right, and we don't have to get X and Y components mixed up in there. So what's the first step when you have connected objects, right? You have to look at the entire system and find the acceleration. And that's going to come from Newton's second law. So in this case, our entire system, right, is this whole thing with two objects. And what's the net force? Well, you may notice that the tension is internal to the system, so we don't have to consider the tension. These two forces cancel out, so the only leftover force is this guy, M2G. So M2G becomes the net force over here. However, we're looking at the entire system, so we have to consider the entire system's mass. And in this way, you would be able to solve for the acceleration. Clean this up a little bit. All right. So here's an example problem. All right. Again, considering the entire system there. Right? We're going to need to find the acceleration of the system and then focus in on one object to find the tension. So how do we find the acceleration? Well, we look at the whole system, right? We already talked about this before, that the net force is going to be M2G, and that gives us the ability to find the acceleration is 3.3. Now, we're going to need that, right, to do the next part. So in the next part, we can't consider the entire system anymore. We want to know the tension. We need to pick a different system. We need to pick one of the two objects. So the question is, which object's easier to deal with? Well, there's no friction, so it really doesn't matter too much. M2 just happens to have fewer forces on it. There's no normal force, so let's pick that one. All right. If we do that, same thing. We need to figure out what's the net force. Well, in this case, let's see. There's mg. We'll say it's m2g, right? Going down. There's going to be some tension going up. Are they balanced though? Well, the whole thing's accelerating like that way, right? So the force that's going to be driving that acceleration that's bigger is definitely m2g. So it's like that. So because of that, we actually make, if we were going to say the acceleration is positive, we have to make m2g positive as well. So, you could have it set up that it's t minus m2g, but then you're going to get a negative acceleration. I mean, either way works. This is just the way that I would do it. And then you're able to find T is 33 newtons. So in these problems, just be methodical, identify what system exactly am I looking at, what's the total mass of that system, what's the net force on that system, and go from there in order to find what you're looking for. All right, so please answer the questions in the forum below, and thanks for watching.